In this video, I'm going to show you how to read a plasmid vector map to determine the fragment lengths you would get after a restriction enzyme digest. This is a map of a plasmid vector. In the middle, it tells you its name. It says it's PGEM, which is the name of the vector, and after the hyphen, that's the name of the gene that's been inserted here. It's the thick gray line is our inserted gene, HNRNP-A2. And then in the other number, the 4,220 base pairs, tells you how big is this plasmid. And there's a lot of stuff going around on the outside. What those things tell us are the restriction enzyme sites, how many there are, and then some other information like where the primers are that made the gene that we were inserted here. But what we're concerned with for this video is how could we tell if we were going to do a restriction digest, how big would our fragments be when we run them out on a gel? So we know the whole thing is 4,220 base pairs, but where is the beginning? Well, the only number I see is a 42 for my lowest and a 4108 for my biggest. That means my origin, my zero, is somewhere here. So then after zero would be 1, 2, 3, and then there's 42. After the base location, it tells you the restriction enzyme that would cut at that spot. So the first one we see at spot 42 is a NOT1 enzyme site. The number in parentheses after it tells you how many of the sites for that enzyme are on this vector. So the NOT1 has a parentheses 3 after it, meaning there's going to be 2 more sites where NOT1 is going to cut this plasmid. So we look around, and here's one down here, and here's another one here. Our total of 3 NOT1 restriction sites. Well, if you have an enzyme that only cuts in one spot, we call that a unique site, and you'll only get one cut. So let's look at what would happen if we did a single digest with the enzyme SPE1. SPE1 is down here at spot number 1269. Sometimes we'll call it SPE1. If you cut with SPE1, it only cuts in one place. So you take a circle and you cut it right here, and we say that that linearizes the plasmid. So now instead of having a circle, you would just have a straight line. You wouldn't lose any bases, so it's still 4,220 base pairs in length, only now it's a long line instead of a circle. That means it's going to run slightly different on a gel. So when you do your single digest, you should expect to see a slightly different band for the linear versus the uncut plasmid. But what we normally do is what's called a double digest, where you put 2 different enzymes in at the same time. And what they do is they cut at all their spots. So if we did a double digest with SPE1 and PVU1, if we look at all the spots, SPE1 only had one restriction site, down here at 1269. PVU1 has 2 sites. There's one here at 2,982 bases and one here at 4,078 bases. Since we have 3 restriction sites, we're going to make 3 cuts. That means we're going to make 3 fragments. One between the 2 PVU sites, one between the second PVU site and the SPE1 site, and one between the SPE1 site and the first PVU1 site. So what we need to know is how big are those fragments going to be? Because maybe we wanted to keep one of them, or maybe we're just trying to make sure that what we had in a test tube was actually PGEM HNRNP-A2. So we need to do a little bit of math. The easiest one, I think, to check is between the 2 PVU1 sites. So we've got the first site at 4,078 bases, and the second site at 2,982 bases. Well, if you subtract those 2, the difference between here and here will tell you how many bases that length would be. So that would be 1,096 base pairs. So if you run that on a gel with a 1 kb ladder, we would expect this to run just behind the 1 kb mark. The next easiest one to figure out is between the SPE1 site and the first PVU1 site. The first PVU1 site is at 2,982. The SPE1 site is at 1269. So if we subtract those 2, we will get the distance between the 2 sites. So when you subtract that, you get 1,713. So that means when we run it on a gel, this fragment would run farther behind the one between the 2 PVU sites. The last one is a little bit more complicated. because we noticed that the second PVU1 site was at 4,078 bases, and then our 0 was up here. And we have to go through the 0 and then all the way down to the SPI1 site. So the first thing we need to do is say, this thing had a total of 4,220 bases. So if we made a cut at 4078, the difference between those is 142 bases. So from this site to our 0 is 142 bases. Then we had to go from 0 all the way to 1269 to get to the SPI1 site. So basically I just need to add 142 to the 1269, I'm adding this time, and I get 1411 for my base pairs. So this fragment would run in between those two. So if I've got my gel and here's where I load it, then the biggest one, the 1713, would run back here. The middle one, the 1411, would be a little bit farther up, and then we'd have the 1096 that would go the farthest, and we would run that against a 1 kV ladder.